Good morning, Houston. My name is Paul Kuepfer from VadaTech. And VadaTech is a company that's dedicated to bringing the latest and greatest technology to our customers and offering it in standards-based platforms. VadaTech has been based in Henderson, Nevada for 11 years. And historically, we've been focused on delivering our technology in primarily MicroTCA and also in advanced TCA. We've started our company doing most of our technology in I/O and in infrastructure products. Later, we added the chassis products, we added FPGA, we added processors, and shelf management, and most recently, we added the FMC products. We really offer complete soup to nuts in terms of embedded computing. One of the major announcements that we're making this week is that we're also going to port our technology into some of the other form factors. Our FPGA cards, we're going to offer them in PCIe, and many of our products we're also going to offer in VPX. Open standards are highly desirable by governments and by many of the prime integrators. Open standards platforms are growing. According to the numbers from IHS, VME and VPX are growing approximately 1% compound annual growth between 2012 and they forecast us all the way to 2017. MicroTCA and ATCA are growing a little faster at 9%, and VadaTech has certainly seen growth far beyond that 9%. Military or modular off-the-shelf and commercial off-the-shelf also deliver to our customer base lower development costs, lower long-term production costs, faster to market. A number of the speakers here have talked about avoiding vendor lock-in. And while we all talk about avoiding vendor lock-in, the real truth is that we all like how expensive and how difficult it takes and how much time it takes for our customers to switch. So I trust that the media here will keep our secrets safe. I'm going to be talking today about a number of trends that we see in embedded. We'll sprinkle in a couple product pitches. But one of the things that we've noticed in our customer base is that FMCs are very widely used across multiple architectures. Advanced TCA, custom baseboards, MicroTCA, VPX, and also PCIe edge cards. We see that this trend is going to continue. We've also done, and I think 4DSP alluded to, some of the other ways that we can stack FMCs to take advantage of several FMCs in a single FPGA. We see that this trend will continue and will go across multiple architectures. The next trend isn't new for anybody. There is rapid silicon innovations. And all of us have been involved in projects where we take the image from 24 server cabinets down to 2, going from a 9U chassis to a small form factor board. And that trend is continuing. FPGA, ADC, DAC parts, system and chip, these advances are shrinking systems and shrinking systems rapidly. On the bottom, you see the newest Xilinx Vertex part, the XCUV 440 part. This part we're announcing this week as well. It's roughly the price of a Benz. And although it has a very narrow application, typically very heavy compute, such as ASICs emulation and development, other parts in the UltraScale part family are much more interesting for the military aerospace customers. On the side, we have a couple of pictures coming, and they're flashing through. We have one AMC that has an UltraScale KU115, and that has a 56 gigasample ADC part on it. And another one has an FMC. We're also going to be developing products that have dual FMC in a 6U VPX or in a double width EMC. Staying ahead with technology is expensive. It's expensive, especially because most of our customer base doesn't like to pay for NRE. A couple wrong bets by us, all of us that are the vendors in this space, means our companies also get canceled, and we've seen a lot of that happen in our industry. The barriers for new entrants, especially in data acquisition, are becoming higher and higher. It's much different to go from kilosamples to megasamples to gigasamples in terms of sampling. The next trend that I'd like to talk about is shelf management. So shelf management has not been broadly used to date in aerospace applications. They're slow to adopt and probably slower to adopt than many of us in this room thought that they would be. Shelf management was originally came in from ATCA and MicroTCA as a telecom spec. And in many military applications, fault tolerance isn't required. In other applications, fault tolerance or shelf management can smack of indeterminism and cause a lot of complications to systems integrators. However, there are several features that are of interest for some of our military aerospace customers. The first one I'll talk about is configuration management. Years ago, and maybe even still, when a ship goes out for 12 or 18 months, when it comes back into port, a sailor needs to go pull every VME board out, write down the serial number, go back, compare the log to when the ship went out, and try to figure out what happened during the mission. With shelf management, this comes automatically. It can be done electronically, it can be done remotely. Also, shelf management you can set up so that it prevents a sailor from plugging the wrong board into the wrong slot. It just will not turn on. The second feature is cold start. Cold start in the tank that's there, you might have to operate in an environment of minus 40 C. And as we all know, extended temperature components are more limited than commercial components, and they're more expensive. What cold start allows you to do is to monitor the temperature in a system, bring it up to a certain ambient temperature, and then turn on the system. And that allows the integrators to operate and develop with much lower cost. Battle short is also a technology that's been around for many years, and that simply refers to the ability of a warfighter to prevent a system from being shut down during a battle event. Now that all of our systems are electronic, customers require or desire the ability to electronically put the system into battle short. So a fan failure or a board overheating won't prevent a missile from being fired. Trend 4, tools to shorten development times in sensor processing. Historically, VadaTech has a very large library of FPGA and FMC cards, and we ship with these cards sample code that allows developers to develop their application from ground up. But this takes a very long time and can be very expensive for the customers. So today we're also announcing that we are releasing a tool set that allows developers to begin their application prior to receiving the hardware. This also makes it much easier to port across multiple architectures, from PCIe to VPX to MicroTCA and ATCA. These tools are based on open standards. They're based on tools that engineers are used to using, including LabVIEW and Simulink. So in Simulink, the engineer can set up the triggers, they can set up the sensor thresholds, and also during acquisition, they can monitor real-time CPU usage, transfer speeds, memory and memory buffers. So again, back to what VadaTech is doing, we are porting our IP across multiple architectures. The customers want to be able to make their choice for the hardware architecture based on cost, based on the environmental factors of where their application is going, and based on what their install history is, what their level of comfort is. The 4 boards that are pictured there give an example of VadaTech products for Xilinx Vertex 7 FPGA boards. There's an AMC, there's a PCIe Edge card, an advanced TCA. This advanced TCA actually has 8 glued down FMC modules, and also VPX. So with over 300 boards that we're going to port to different architectures, yes, Houston, we have a problem. We need a bigger boat. Okay, thank you.